All right, line V1, learning task number 11, braking methods. This is going to be the second video that we're going to go and cover inside of here. We are going to go and take a look at plugging control circuits for braking. Plugging is just where we are going to go and have a motor that is going to be running in one direction, forward, or let's say, and then when we want this thing to go and stop, we are going to go and provide a reversing torque. We're going to go reverse the lines that are coming into this thing just so that we can go and slow this thing down. Now, we have to be very careful that we only slow this thing down to the point that it's going to go and be at 0 speed. Once we go past that 0 speed, we are then going to start operating into reverse, and that's not the point. This is not supposed to be a reversing type of installation. This is supposed to just be a plugging installation, which really just means that we want to only apply the reversing, or in this case, we're going to go and call it the retarding, the slowing down. That way it could be neither forward or in reverse, but we want to go and provide the slowing action only for as long as it takes for us to get down to 0 speed. A couple of different ways that we can do it. First way, that's the simplest, is for us to just go and throw in a time delay relay. Once again, if I go and take a look at my drawing over here, I see that in reality it's just a simple 3-wire start-stop that I have that is going to be running my motor in forward, but then I'm just going to add in a few extra components over here, a time delay relay in parallel with my forward, and a set of timed contacts over here, set of time contacts over here that are then going to go and tie us in. A couple of things that we are already aware of. One, mechanical interlock so that I cannot push in both coils at the same time, whether manually or electrically. Two, I'm going to go and have electrical interlocks. Anytime that the reverse one is powered up, those contacts will be open, preventing us from providing power to the forward. Anytime that the forward is powered up, these contacts over here would be open, preventing us from providing power to the reverse. Those are going to go and be our electrical interlocks that we will have. Going through the operation of this one, pretty straightforward. We carry power through all the way up to here. If we take a look at this here, we see that we have got a time delay type of component over here. It is normally open, time to open. Note how the arrowhead is going down. NOTO. Which means that it is working off of an off delay type of timer. You have to be able to go and identify and infer which type of timers you are going to go and have just based off of the contacts that we are going to go and see over here. If we take a look at this one, the second that we go and apply power into here, we provide power through there, which is going to go and carry power through to the forward coil, which is going to go and close this over here, which is going to go and open this over here. And instantly, as soon as we provide power to an off delay, it is going to go and close as well. Let's first carry through this top rung over here. So we see that our start is going to close, which provides power all the way through. That's then going to go and seal in. So we can take your finger off the start push button, and we see that we provide power as well to the off delay relay. That off delay relay, as soon as it gets power, it is going to go and close. And then it is going to go and provide power through up to here. So that's as far as that power can go and advance. We run this motor for as long as we want. At some point, we are going to go and have to hit our stop button. When we hit our stop button, we are going to go and drop out all of this forward and time delay. And we know that the action of an off delay over here is going to be that it's going to start timing now that we have dropped out power. Tick, 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 tick. As long as it takes for the time, let's say this thing times out 6 seconds. At the end of those 6 seconds, it is going to go and open. Oops, sorry. I should back this thing up a little bit. The second that I depowered this one before we started the timing, so how about I just start it from back over here? This would make more sense. 2 seconds. We're going to go and restop this motor, okay? I missed an important step that I should explain as we're going along. Once again, stopping the motor over here. As soon as we hit the stop, we're going to go and open this up, drop these out, and we're going to return this to its default position. So I'm going to hit stop. As soon as I hit stop, it is going to drop out that forward contact. As soon as it drops out that forward contact, that is going to go and reclose this, and this stays closed because it's off the timer. Tick, 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 that timer that's going, which means that because that dropped out, now we are going to have power provided to our reverse at this point. So my motor is going to be running in reverse for as long as this timer counts. This might count down, let's say 6 seconds here once again. At the end of the 6 seconds, this normally open, time to open, would go once again open, which would kill power the rest of the way through here. So we would just have our forward operation, if I look at these arrows up here, basically unlimited. I'll just write that out as infinity, it's far easier. Is going to be unlimited, but then my reverse operation is going to be based off of a specific time, whatever I program this timer to go on hand. Now I have to be very careful about that, because if my load would change, if I would have a load that's always heavily loaded, and so I got a lot of inertia and it always takes a certain amount of time to spool down, this would work. But if all of a sudden that load was lightly loaded, that plugging would go and actually stop the motor, bring it down to 0 speed, and then it would start to reverse it into the opposite direction, because it would be able to be so much more quick about its retardation of that motor itself. So it can be a dangerous one because it doesn't actually know when the motor is stopped, and there's that danger that it has potential for reverse. Potential to reverse. Okay? We don't like that if something's going to go into reverse, so what we'll often do then is we will go and use a 0 speed switch, or what we refer to as a plugging switch. Plugging switch is just going to be a switch that is going to be held by the motor motion itself. Whether that motor is running or whether that motor is coasting, it is going to go and be held closed. Once again, looking at our power for this one, we would see that we would have power brought through up to this point at all times for this motor. As soon as I would press my start button over here, that start button is going to go and provide power through. It's going to energize the F, which is going to go and close that over there. So the very first thing that happens is this thing passes through, energizes our forward motion. As soon as it energizes that F contact, it is going to go and open up these ones over here, and it is going to go and close this set of contacts right over here. And the motor, so we've only just closed this in, the motor is going to start coming up to speed. So you can figure out that push button. As the motor comes up to speed in the forward direction, it is going to go and close this switch, and we will see that this is now going to go and provide power through to this control relay over here. Because the motor is running in the forward direction, the control relay is going to power up, which is going to close this set of contacts, and we now have power all the way through here. This thing is going to be sealed in on this lower section. We can run my motor now for an unlimited amount of time, and then at some point we are going to go and hit our stop. When we hit our stop, we're going to lose power to the F and all associated contacts. So we're going to hit stop, we're going to lose the F over there. As soon as we lose that F, we are also going to go and lose that contact over there, but it doesn't matter, we're still sealed in. And right now, we are still coasting in that forward direction. So this is going to be held closed over here. This is also going to go and seal back in. Because my CR is sealed back in, it's now going to go and provide a reverse to this motor. So this motor is going to begin plugging down to a stop. It's going to be slowing down. As it slows down, it's eventually going to get to the point where it's got no more forward momentum. When it loses forward momentum, this switch over here is going to open, which kills my CR, which in turn is going to go and kill this circuit over here. Brings us back down to a completely reset motor. So this is speed sensitive. It's a very, very good thing that this thing is going to be speed sensitive, because now we know that we are guaranteed we cannot accidentally go and drive this thing into reverse. Why do we have this control relay inside of here instead of having this reverse just directly connected to this? The reason for the control relay is going to be just so that we don't have any option where somebody could go and push this thing. Let's imagine it's attached to a giant saw blade, and if somebody pushed the switch closed, normally we would have power up to here. If somebody were to go and push this thing closed right now, we would go and carry power through, but because that's not energized, it would not be able to make it in, and because this is not energized, it would not be able to go and make it in as well. If you compare that to the plugging control circuit that you had inside of learning task number 2 of this whole setup, where they're talking about plugging switches, you can see that they had a different one where they just had that reverse directly dropped into here, and they said that's a dangerous thing, and then they had to go and add that other lockout coil. This is a better circuit over here. It just involves the use of one more small component, but it's a fairly cheap little control relay, one of those little 8-pin or 11-pin relays. If I've got a motor that runs in both forward and reverse, I'm going to have a more complicated plugging circuit. I'm still going to go and plug this thing to a stop, but I need it to be able to go and apply a reverse when I'm operating in forward, or apply a forward when I'm going to be operating in reverse. And this one, there is really no way about it. We have to go and have a lockout coil that's going to be attached at the motor. The lockout coil is basically going to go and be a spring-loaded type of device that is going to go and prevent this thing from moving until it has been energized. As soon as this thing has been energized, it's as if I've got, here, we'll stick those on there like that. It's as if I've got this little block over here that is preventing that switch contacts inside from actually operating. And as soon as I would go and take my, provide power to this whole thing would move out of the way, which would allow that little swing arm to go and move. I've represented it, with pins in some of our other ones. This one here, we'll leave it with these two, kind of bars on either side. It is not a cord end. Please don't think about it like that. These are just pins that are physically preventing this thing from moving. It's a physical component inside of here. Once again, if you were to go and follow this thing through, and we'll only follow it through, this time just in the reverse, you would see that we have got power that is going to be carried just up to there. Take that one out right now. Because power is carried up to there, we see that we aren't hitting any of our coils. We do see that once again we have got our electrical interlocks as well as we have got our mechanical interlocks that are going to be associated with the coils and the contactors. This is good. And now we go and press our start button. We're going to press our start button in reverse. As soon as I press that, we are going to go and carry through a normally closed contact over here and normally closed contact to the R, my reverse coil. And when I hit the reverse coil, it is going to go and seal in its reverse over there, as well as simultaneously opening up this one over here. So we hit that, which means that this is now going to be energized. We're going to start operating in reverse. We can go and open this one up over here. We don't have this sealed in yet because we have not gone and operated this, but because we are running in reverse, because we provided power to the coil of our motor, the lockout solenoid is going to go and retract, which means that this is now going to be free to swing, and because we're operating in reverse, it is going to go and swing down to here, which means that CR2 is going to go and be energized, which means that I'm going to go and have operation off of this CR2 over here and this one over here, which is going to be closed now. And because that one is closed, we're now going to have power through and up to there. So we're going to run this motor for an indefinite amount of time in reverse. Then at some point, we're going to go and hit stop. When I hit stop, I'm going to go and lose power to all of my coils, but I'm going to still have rotational force on this. So I'm going to start by just hitting the stop over here. We're going to lose power to all of my coils. So all of my coils go back down to their default. And as soon as I take my finger back off of that stop over there, what I'm going to see is that power gets reestablished all the way up to all of these contacts that were being operated. And if I take a look, this is the important one, it's going to hit this, which is still being held up against there by the coasting motion of that motor, which is going to have operated CR2 then, which is going to go and close this, which means that it is going to be able to go and pass through here. And we are going to go and operate this thing now in forward. Remember, we were running in reverse. It's now going to be operating forward. It's going to just open up any sort of forward contacts that we are going to have. It's going to go and close this one over here, but these ones over here are open, so it's not actually sealing in through that set of contacts. And so right now we are going to be plugging this thing down into a reverse. So the motor is going to be slowing, and eventually it's going to hit the point where this thing is going to, because we've once again energized the solenoid here, the solenoid here has not been energized, so this little set of lock dogs is ready for this thing to grab back in. Motor slows down. Once the motor slows all the way down, it is going to go and open this circuit. When it opens that circuit, this thing swings back into the middle where it's automatically caught by the dogs. And as soon as that opens, that CR2, this one over here is going to go and open up, which is going to depower us in the forward direction. This one returns to its at-rest state. This one here is going to open just a slight bit ahead of this one here, reclosing, because we did have that one powered off over there, so that this thing does not go into a forward operation. It's a bit more complicated for sure. You know, we need to have two control relays, one control relay to lock out the reverse, one control relay to lock out the forward, as well as we need to have that lockout solenoid. But it does allow us to get rapid deceleration of that motor. Once again, because we're looking at plugging, it is hard on our systems. Just all around hard for the amount of current that we are going to be pulling in. Not that it's unusable or anything like that. That's not what I'm saying. You know, please don't read it as that. I'm just saying it's hard on our equipment because we get a lot of inrush that we have to go and deal with all of these types of situations. Okay, advantages. Advantages of plugging is it is our fastest deceleration method. Basically, we're trying to accelerate in the opposite direction, so it just decelerates really quickly. We've got no friction parts, so we don't have any real maintenance off of the system. We have got, you know, contactors that we have to go and maintain, keep those clean, but those things should last more or less indefinitely. And it's suitable for large motors and severe duty. Provided I've got the power on site that I can take that, you know, massive amount of inrush when I reverse it, it's absolutely going to go and be fine. The disadvantages are that it's going to require a larger set of controllers, reversing controllers, and it is going to require a zero speed switch or a consistent time delay relay that is based on a load. So it really just means that we need to have a consistent type of load, so we can use the time delay type. That's going to be this one over here. If I've got the exact same load every single time, I could use the timed one. Otherwise, what I'm going to do is I'm going to have to go and have that zero speed switch. And then the other really big one about this one is that it cannot go and break if we have a power failure. If you get, you know, hydro goes out, that motor's just going to go and coast down. And if it takes a long time to coast down and that's problematic for your system, there's absolutely nothing you can do about it. It's just going to go and coast its way to a stop because it needs power in the reverse direction if it is going to go and stop. And because it doesn't have a physical stop, that means as well, once we bring this thing to a stop, or once it comes to a stop, there's nothing holding it. So it can actually get pushed, you know, forward or backwards, particularly when you've got like large, heavily loaded belts that are going on an incline. There's going to be times where, you know, that belt has a tendency to want to go and draw down backwards. Motors themselves, usually you're best off to work with like inverter duty type of motors, which are going to have a better braced set of windings inside there so that they don't get moved around as much by the magnetic stresses. It's that hard slamming back and forth caused by magnetic stresses that even those on a microscopic level tends to fracture the insulation and cause breakdowns inside of these ones as well. Okay, that is it for my plugging. We're next going to move on to my dynamic braking.